Alright, so I'm going to show you what I think is a better way to balance chemical equations. As a brief reminder, we would need the same number of atoms of each element uh, before the reaction happens and after the reaction happens. Right now we can see this is not a balanced chemical equation because I have two oxygen atoms, but I only have one oxygen atom after the reaction. So I know that this is currently breaking the law of conservation of mass. So let me show you my strategy for balancing. Now this is a really easy one to balance. You probably can see how to make this balanced right away. But I just want to demonstrate what my strategy is. Here we go. So the way that we start is by drawing one of each of my reactants. So there's my one magnesium atom, and then here is my oxygen molecule. And then what I'm going to do is I'm going to rearrange those atoms in order to turn them into magnesium oxides. And when I say use them or use them up to turn them into product, that means like this. I'm going to cross it out and move it over here, right? And that's showing that I'm starting to turn it into product. So I'll do that with one of my oxygen atoms as well. And now I can see I've made one magnesium oxide, one MgO. But I have another oxygen left over. He doesn't get to just stay there. All of the reactant is going to turn into product. So he's also going to be moved over. The problem is I cannot add him onto this magnesium oxide because that one is finished already. So I'm going to start a new magnesium oxide down below. And now I haven't made a magnesium oxide yet, so I need to finish it. What is he missing? He's missing a magnesium. So I'm going to grab another magnesium from the pile, and I'll quickly use it in order to make to finish my magnesium oxide there. This kind of process is kind of similar to what we were doing when we were doing this, right? Uh, we see that like magnesium doesn't get to keep his electrons and oxygen's always going to get to 8. It's kind of the same idea here, where our reactants don't get to stay reactants and our products have to be products, if that makes sense. So all my magnesiums just turn into magnesium oxides. Once I get to this step where everything is, all my molecules of product are finished and everything is crossed out from my reactant side, I'm done, and I can just write my coefficients now. I can put 2 because that's how many I used. I only used one oxygen molecule, and I made 2 magnesium oxides. So that's how it goes. I'll show you another one so you can get the hang of it. Like here, I'm going to start by writing HHOO. That represents my hydrogen peroxide here. And then I'm going to cross those out and move them across in order to turn them into product. So I'll move these first. They're going to start my water molecule there. I only need one of those O's in order to finish my water molecule. The other one, I guess, is just going to have to become oxygen by itself. But now I see I need more of that, right? I need another one to finish this oxygen molecule. So what I can't do is I can't just bring in an oxygen atom and then cross it out and move it over here. You can't do that because, well, oxygen atoms are not in my reactants, right? My reactant is hydrogen peroxide. So I have to bring in an entire molecule of hydrogen peroxide just to finish that O, right? And now we can see that, yes, that brings in more atoms that we have to deal with now, but that's okay because that really quickly resolves itself. I can use those remaining atoms to make another water. And now I'm done, right? Because I have finished all of my reactant molecules and everybody's finished over here. There's no incomplete molecules. So now I can just tally up 221. And that's pretty straightforward. I'll do another one. AlBr3, so I'll go Al, Br, 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 and Cl2. So ClCl. I'm going to cross those out and use them to make my products here. So this Al goes here. These two BRs are going to pair up. These two, I guess this BR will start a new bromine molecule. These two Cls can go there, but we can see we need a third one because it's AlCl3. So I'll go ahead and bring in another chlorine molecule, and then use one of those to finish that molecule there. This one is going to have to start a new chlorine molecule. And then hopefully you can see what the next step is here. I can go ahead and do that. I need another AlBr3 because not only do I need to finish my bromine, but I also need to finish my aluminum. So that's why I brought in that extra aluminum bromide. The important thing is that you can't put anything on the product side without first crossing it out from the reactant side. If you follow that rule, you'll never mess up. But if you're going to mess up, that's the rule you're going to break. I've seen it happen a whole bunch. Just don't put anything over here until you've crossed it out from this side, until you've written it and crossed it out. Otherwise, you're gonna forget and make mistakes, and it's gonna be a mess. So now I'm finished. I'll go 2, 3, 2, 3. That's pretty straightforward. NaOH, this one's going to be kind of annoying, but we can do it. What's going to help us is noticing that this CO3 right here, that's a carbonate ion, and the carbonate is always going to stay a carbonate, like it stays together. It's present on both sides of my reaction, in the reactants and the products. So I'm not going to bother breaking it up into C's and O's. I'm just going to treat it like one thing, just like we do when we're writing like formulas for ionic compounds. So here I'll go NaOH and then HH, and I'm just gonna leave the carbonate like that as a CO3 because it's gonna move across, like it's gonna move over here as a CO3, so he gets to stay. I'll just move these two H's as well, and then I'll move the Na. You can see we need another Na right here. But first I'm going to finish my current reactants. So I'll move this O right here. This H is going to have to start a new water. And now I've spent all of my first batch of reactants. What do I need more of? You can see I need another Na right here. So I'll go ahead and bring in an NaOH since I can't just bring in an Na by itself. That'll help me finish that sodium carbonate. And I can see this OH, that's really convenient. That'll help me finish my water right here. And now I'm done. Yeah, now I'm done because I've used all of these up entirely and all of my formulas are finished. I don't have any unfinished molecules. So I'll go 2, 1, 1, 2, and that's that. So as you can see, this method of balancing chemical equations might take a little bit longer. It's a lot of writing, a lot of drawing atoms, but if you're struggling to do it in your head, I recommend doing it this way. Eventually, you probably want to graduate off of this and just like start looking for patterns. And I'm sure you'll find some because it's not that difficult. To start doing it in your head, but you can do it like this for a little bit. Cool. Alrighty, I hope that was helpful.